The next problem we're going to do is trying to find trig values using the half angle formulas without actually knowing the angle. Okay, so we may not need to know the angle, just some information about it. In this example, we're looking to find the sine of x over 2, given that the cotangent of x is -3. That's all we know, that, and that x is between pi over 2 and pi. Well, what angles are between pi over 2 and pi? That would be what, the fourth quadrant, right? Or I'm sorry, the fourth quadrant, the second quadrant. So this would be in the second quadrant, pi over 2 to pi. So what I want to do is use the half angle formula to work this out. Now, to use a half angle formula, I need the cosine, not the cotangent. But we can get the cosine by constructing a right triangle and using this -3 to give us information about the sides of the triangle. So if I were to draw out a right triangle here, and I put x as one of my angles, -3 is the cotangent. Remember, the cotangent is the reciprocal of the tangent. Tangent is opposite over adjacent, which means the cotangent is adjacent over opposite. So if -3 is the cotangent, then that would be an adjacent side of 3 and opposite side of 1. Okay. Now, the negative I'm going to ignore for just a moment. I do know that x is in, like I said, the second quadrant. And so that would mean the x value, the adjacent side would be the negative, the vertical side would be the positive. But again, I'm going to hold off on that because we can work all that out at the end. So what I need to know is the hypotenuse. The hypotenuse is found using Pythagorean theorem. It's the square root of the sum of the squares. So you get 9 and 1. 9 plus 1, of course, is 10. So this is the square root of 10. Okay. So the hypotenuse is square root of 10. And that tells us then that the cosine of x is the adjacent over hypotenuse, which is 3. I should probably give myself a little more space. 3 over root 10. So we'll do this. Cosine of x equals 3 over square root of 10. Of course, we want to rationalize that, so we'll multiply top and bottom by root 10. And that gives us 3 root 10 over 10. Of course, there's one other thing to consider. Always need to consider this. It's an easy thing to overlook. And that is our Astc diagram. The angle x, we know, is going to be in this second quadrant somewhere. The cosine in the second quadrant is negative. Cosine is only positive in quadrants 1 and 4. So I should add a negative to that value. Okay. Now that I know the cosine of x, I can use my half angle formula or half angle identity to find the sine of x over 2. So the sine of x over 2 is equal to plus or minus, and we'll determine this in just a moment. We'll come back to that. Plus or minus the square root of 1 minus, instead of cosine, I'm going to put that expression that we just found. So it's a -3 root 10 all over 10, and then divide that whole thing by 2. Okay? Coming back to this plus or minus, if pi over 2 is less than x is less than pi, that gives us an inequality, that gives us a way to find a range for the x over 2 angle. So if I know this relationship for x, to find x over 2, I just need to divide the middle term by 2. But if I do that to one part, I have to do that to all the parts. So I can divide everything by 2. Okay? Well, dividing everything by 2 simplifies. Pi over 2 divided by 2 is pi over 4, right? Half of pi over 2. So what I would end up with is the inequality pi over 4 is less than x over 2 is less than pi over 2. So if this angle x over 2 is between pi over 4 and pi over 2, equivalent to a 45-degree angle and a 90-degree angle, if my angle is between 45 and 90, that means it's got to be in the first quadrant, right? So x over 2 is somewhere over here in the first quadrant between 45 and 90, right? So x over 2 being a first quadrant angle means the sine is going to utilize a positive value, right? Sine is positive in the first and second quadrants. All right, so we know we're going to use a positive, then I can go through and simplify this. So I'm going to have the positive square root of 1 plus 3 root 10 over 10 all over 2. Let's see, I should get a common denominator here, so we're going to do some simplifying. And ultimately, I want to get this into one nice fraction. So 1, to get a common denominator with a 10, is 10 over 10. So this becomes the square root of 10 over 10 plus 3 root 10 over 10 all over 2. All right, get the two fractions on top together. That will become 10 plus 3 root 10 all over 10, and then all over 2. When you take a fraction divided by 2, we've talked about this before, it's the same as doubling the denominator, or multiplying by 1/2. And so you could think of this as 10 plus 3 root 10 all over 20. And of course, I can split the root between the top and the bottom here. And so I am going to start running out of space, but that's okay, we'll fit what we can in. So that's the square root of 10 plus 3 root 10 all over, now the square root of 20 simplifies. Right, that's the square root of 20 on the bottom. Square root of 20 is really 2 times the square root of 5. Right, if you split the 20 into a 4 and 5, take the square root of 4, you get 2. So it's 2 root 5. So this becomes the square root of 10 plus 3 root 10 all over 2 square root of 5. Oh, now the crazy part is I've got to try to simplify further. I really don't want a root on the bottom, so we want to rationalize this denominator. I got to multiply top and bottom by root 5. Is this really necessary? I don't know, but I feel like my math lab will want you to do it. And I always encourage denominators to be rationalized, so we should go through it. Well, this is interesting. I've got a big root and another root on top. When you have two roots multiplied together, you can combine the stuff underneath into one root. So I could do the square root of 5 times 10 plus 3 root 10. If that makes sense. So I'm combining the 5 times the stuff under the other root. And then on the bottom, I've got root 5 multiplies to 5 times 2. 5 times 2 is simply 10. Okay, so I got a 10 on the bottom. I could probably move, kind of distribute that 5 through. So ultimately, we're looking at the square root of 50 plus 15 root 10 all over 10. And although that is complicated, I think that's as simplified as we can get. No more roots on the bottom. And there's really not any way that I can simplify any of the other roots. So that looks like a good answer. I'm gonna double check that with a similar problem in the book. Yeah, I think that's exactly what they'd be looking for. So this would be a good answer. And of course, you can always verify these just to make sure you haven't made a mistake, because obviously there's a lot of weird simplifying going on here, right? Just plugging in that first thing, you know, that's the only use of the formula itself is this first step. And after that, it's all a bunch of radical simplifying. But you can always verify on the calculator. Oh, you can't on this one. Never mind. That won't work. I don't know what I'm thinking, because we don't have an angle to plug in. We don't know what that actual angle is. So I guess we've just got to deal with this. But that's correct. Just be careful in the simplifying that you do, you know, to make sure you're combining your fractions correctly, you're getting your LCDs. This is a tricky one. When you take the square root of the 20, it does become 2 root 5. So there's a lot of little details in here, lots of places that are easy to make mistakes. So you just want to be very careful in doing this. This would be the answer that my math lab would accept as far as I know. All right.